I think it's pretty obvious that AI is going to be dominating every aspect of life for the next decade, maybe even the next 100 years. Some people are saying that it's actually going to be the base layer of reality pretty soon. Now, regardless of how bullish you are on the advancements of AI over the coming years, it's going to be a part of your life in some way, shape, or form. And so what I wanted to do was create a fundamental course about what AI actually is under the hood. A lot of people talk about AI, but I don't think they actually understand how it works beneath the hood. And so if you're someone that runs a business, you have a well-paying job, you are just a regular person that wants to be able to use these tools in the best way possible to improve your life as much as possible. Regardless of the scenario, the deeper your understanding of artificial intelligence, the better your outputs and quality of results are going to be. And so what I want to do is put together a course. I'm not sure if it'll be 5 videos, 10 videos, 15 videos, but this is going to be everything you need to know about artificial intelligence. And no, this isn't going to be how to prompt on ChatGPT. We're talking things like what are LLMs, which is the actual topic of this video. We'll talk about things like what are vector databases, what are vector dimensions. There's all types of aspects of AI that's under the hood that people are not considering, including things like, what is JSON? How do you use JSON? And so on and so forth. And so if you have been wondering, what is AI? What does it actually mean? What is happening when I go into ChatGPT and I type in a question and I get a result, in 0.2 seconds? What's actually happening there? This course is for you and it's 100% free. We're not going to be charging for it. And I think you're going to find a ton of value in it. So let's go ahead and dive into the presentation. I tried to make this as simple as possible. Keep in mind, we might cover some technical details that are a little bit confusing, but we will demystify those in later modules inside of this course. So don't worry too much if you get caught up, because this first one especially is just a very broad overview of what LLMs are and how they work. So with that said, what exactly are LLMs? Well, they're sophisticated artificial intelligence systems that are engineered to work with human language. But what does that actually mean? So you might have heard the term natural language processing. Essentially, what these are is a way to communicate with computers through natural language, meaning English or whatever your native language is. In the past, you had to communicate via code, via Python, via JSS, via HTML, millions of different types of code. But now you can communicate via natural language processing. And they're called deep learning models for a reason that we'll cover much later. But the training foundation is very important to understand. So these companies will train the models on terabytes of data. That's a lot of data. And what that means is they'll take Reddit posts, they'll take books, they'll take movie references, cultural stuff, and they will train the models on them. And this has caused a big hoopla in the legal world because there's been a lot of suing and a lot of, should they be allowed to train on this information? Should they have to pay for access to it? And I don't really have an answer to that, and that's not really the point of this video, but what we're seeing now is something called synthetic data, because people thought we were going to hit a wall once the models were fully trained. A wall meaning the training's done, there's nothing else we can do. But there's two things that have been added to the mix that have basically broken through that ceiling. The first one is synthetic data. So synthetic data is basically fake information that is based on context in the real world. And as a result, you can never run out of it because the LLMs can generate synthetic data. There's another one called reinforcement learning. And this is a sort of a confusing term to understand, but the most simple way that I can put it is if you're familiar with the company Tesla. Tesla has autonomous vehicles, or FSD, it's supervised, but you get the point. And what these vehicles can do is train themselves on data from that car and the millions of other Tesla drivers. So this is reinforcement learning. So just as an example, if a Tesla is doing full self-driving and a school bus has a stop sign and it's parked and it has a stop sign and the Tesla goes past that stop sign Then the Tesla user can leave a message for the team and say, hey, I'm in FSD. We just drove past a school bus, and the school bus had the stop sign, and we drove past them, and that's illegal. And so it can take that data and it can work with it and train on it. And this is called reinforcement learning. And so reinforcement learning has completely changed the way we think about training AI models. So you have training on data, you have training on synthetic data, and now you have reinforcement learning. And so all of these models are continuously learning and continuously evolving based on user data. Now, core capabilities. So, interpreting and making sense of human communication, creating written content that resembles human authored text, once again, that natural language processing. But why are they called large? Well, like I just told you, they're literally using terabytes of data. And if you're not familiar with how much that is, I just got a new iPhone and it has 1 terabyte worth of storage. It would take me forever to fill that up. So imagine hundreds of terabytes, how much data can be combined in there. And the models are absolutely massive, and they have billions to even trillions of parameters. We'll talk about parameters in a different video. For now, just understand that it's basically like the amount of context that it can digest at one time. And when you think about models, they're called multimodal for a reason, because they can interpret natural language, they can interpret videos, they can interpret images, they can interpret spreadsheets. So there's a lot of different ways that these models can digest that information and then create new output. The fundamental goal of LLMs is, there's a lot of people that'll tell you ChatGPT, it's just a word prediction tool. Kind of true. I want to push back on that, but bear with me for a moment. Forecasting which word or token should appear next in a sequence. So this sounds straightforward, but basically this simple capability of being able to forecast which token should appear next allows LLMs to produce coherent text that fits the context, provide answers to your questions like you're all using it for, convert text between different languages, filling in incomplete sentences or paragraphs, supporting writing, brainstorming, doing math, and so on and so forth. This is an important concept that we will really drill into later. So you can think of LLMs as an extremely sophisticated autocomplete system. However, what I would like to add to this is now LLMs have reasoning capabilities, meaning they can think deeply and reason the same way that a human would. So before, LLMs were simply autocomplete systems, but now they can do reasoning. So they can take context, they can think about it, literally think in the same way that a human being might think. And so just as an example, if you put into ChatGPT, the cat sat on it's probably going to say Matt as the next word. And that's at the most basic level of LLMs. I'm sure anyone watching this video is using it probably at a much higher level. So how does it actually work? We need to talk about transformers first and foremost. So LLMs are constructed using a deep learning framework called the transformer. So the transformer has 2 parts to it. And I know this is kind of confusing, just bear with me. And this is important so that you can get the most out of your AI use. The 2 architectural components of a transformer are the encoder, which is basically processing and interpreting the incoming information. So information's coming in, the transformer is processing that information. And there's the decoder, and that produces the output response. And there's basically 5 stages to this processing journey. You've probably heard a lot about tokenization when you are or just tokens in general. Well, tokens are the input text and the output text. And the model providers, so OpenAI or Google, they have to pay for every token that is used because it costs them GPU energy. So the GPUs are basically the chips essentially that are running these AI models, and it costs a ton to run these. And so the input text gets divided into smaller units called tokens. And so tokens could be complete words, partial words, individual characters, numbers. It's basically just the context inside the chat window that you're typing in, okay? And it's also the output. And so I'll give you an example. I'm building an AI app right now, and I have to pay for inference costs, and I'm using Google. And so I pay for every time a user puts tokens into the chatbot, and I also pay for the tokens that are being generated by the AI on the output. Now, embeddings. every token gets transformed into a numerical vector. Don't worry about that word. I know it's scary. We're going to have 2 or 3 videos about vector in general, vector databases, vector embeddings. It's a simple I'm not going to call it simple, but it's actually not that complex to understand. But the vector that it shows up in will represent the token's meaning. And so these vectors exist in a multidimensional mathematical space. And so if you think about, okay, I'm going to try, I don't want to go too deep into this, draw. I don't want to go too deep into this rabbit hole. Okay, so a vector table is essentially like this. Okay, so there's a y-axis and there's an x-axis. And every single token is, and I promise we're going to do a different video that's going to really break this down, but let's just use the word cat. So cats can have different vectors assigned to them. So the first vector could be how animal-like it is. So let's say it's at 0.8. Okay, great. And then it's also not a human, so it's at 0.1. Okay, so if this vector is about how much of an animal something is, far and to the right is going to be animal, down and to the left might be an inanimate object, here might be a human being, okay? So the cat is going to show up on the vector database, and I realize you can't see the whole thing, and maybe the cat is plotted right here. And so the reason that I'm explaining this to you is because what happens is there's a lot of different vectors. So the vector essentially represents the token's meaning, and it exists in a multidimensional mathematical space, which is why I kind of showed you this. I'll show you some different graphics that are honestly a lot better. But so stage 2 is the embeddings, which has all to do with the vectors. Then we have the attention mechanism. So this is kind of like the breakthrough innovation behind transformers. And basically all that it does is it enables the models to concentrate on the most relevant portions of input text. Once again, it can say, oh, okay, this is the most relevant portion. So this is probably the right answer that we should spit out back to the person talking to us. And it goes to text generation. So the model predicts the most likely next token using surrounding context from the vectors. The selected token gets added to the growing sequence, and it processes repeatedly and continuously until the full response is completed. So you only need to grasp these metrics enough to use the tools effectively. You don't need to be an expert in this. I can't stress it enough. It's just important to just have a general grasp of how it's using. You'll never need to use this when you're using LLMs. But what LLMs can do exceptionally well is comprehension. So it can process lengthy and intricate passages of text, have natural output, once again, natural language processing. It can have versatility. So I can say, write this in the style of Tony Robbins or write this in the style of Andrew Huberman. And I can say, responding to questions by drawing on information absorbed during the training. A big breakthrough with LLMs was when they added web search, because that opens up a whole new world of information that it can use for the outputs. But some critical things to understand: LLMs can hallucinate. Now, there is a way to mitigate these or minimize these hallucinations, and that is going to be through something called RAG, which we'll talk about in a separate video. But the general LLMs can generate false or misleading content. There was a big case where there was a law firm that was using ChatGPT, and they referenced all this stuff in their case, and it turns out it completely hallucinated and made up the case. Sometimes when you use Grok, it'll literally make up restaurants and a menu and everything. And long story short, that is because these models were trained to be confident and make the user feel confident in them and not accept defeat, essentially. They're working on changing all of that, and this is changing tremendously fast. But you can essentially, like I said, these models don't truly comprehend meaning the way humans do, although that's starting to shift now that we have reasoning. They operate on pattern recognition instead of genuine understanding for right now. I would argue that reasoning models actually completely make this not true. That's kind of up for debate, but that's, my opinion. Now, obviously, there's going to be bias because it can reproduce and it can amplify bias that's present in the training data. So let's just say, for example, you are training this data and you are a diehard Republican or Democrat, take your pick. Well, you can insert data in there to train on it that it makes it think, hey, this is the single source of truth. This is correct. So all in all, the way LLMs work is it uses natural language to interpret what you're putting into the system, and it uses natural language to spit it out. It finds the answer to your question by using vector systems, which we'll talk about in detail in a separate video. But LLMs are chatbots. They're going to be around forever. They're probably in my opinion, the most revolutionary technology that's been invented in the last 100 years, maybe besides electricity. And so it's just important to have a general understanding of how it works under the hood. And if this was confusing to you or you're kind of scratching your head, don't worry, because the following videos are going to make a lot of sense and it's going to break down some of the confusing stuff in there. But this is basics of LLMs. I hope it was helpful, and I will see you in the next video.